Good evening or morning or whenever you might be watching this video. This is exercise 4.1. We get into some truth tables and using them to do things, right? Chapter 4 is all about a couple different things you can do with truth tables. This 4.1 is testing for logical equivalence to see whether two sentences are logically equivalent to each other. Later exercises in this chapter will use truth tables to test for consistency and inconsistency, and then most importantly for our purposes, how to use truth tables to see if an argument is valid or invalid. All right, but we're working on consistency, inconsistency. This is the even numbered problems since the odd numbered problems are assigned for homework. And I am using tables here, which is pretty easy to do. You just hit insert up here, table, figure out how many columns and rows you need, and draw it out. And then you just fill in the T's and F's. There's probably easier ways, especially if you can just rip out your homework page or make a copy of your homework page and fill them in. But we'll use tables for this. Okay, so whenever you're doing truth tables, using them for anything, whether it's equivalence, consistency, validity, the first step is the same in all cases. Fill out the truth table, right? So you just want to get all the squares filled out, or as many as you need, with the most important squares being the ones under the main operators. So here we have two sentences, are conditional S and not are conditional not S. The main operators are highlighted. It's the conditional in both cases. So we need to have at least that column filled in underneath the main operator. So in some cases it's easy. So there's no real need to fill in your R's and S's here because you can look over here at the truth table and see what they are. So in this case, you can just go, okay, the truth table for conditional is F. Remember, conditional comes out false if the antecedent is true and if the consequence false, and otherwise it comes out as true. So that's the truth table for the conditional R then S, if R then S. Now this one's a little different because you have negation. So in this case, you might want to fill in your truth values, which are just going to be the flip, right, of your column. So if R over here is TTFF, not R is going to be FFTT. S is TFTF, so here it's just going to flip all those values, FTF. F and T. So now you can more easily fill out the main operator. So here we have true. True. Remember, anytime the antecedent of a conditional is true, the whole conditional comes out true. Here we have TF though, so that one's false. And last one is true. So fill out as much as you need to get clear on these. Like I said, the key though is that the columns under the main operators be filled out. Okay, so again, I said step 1 is the same in all cases. Fill out the truth table. Now step 2 for 4.1 is determine whether these two sentences are equivalent or not equivalent. The way to do that is go line by line through the truth table and compare. Again, we have to use the column under the main operator. That's why sometimes, like if I'm doing these by hand, I cross these columns off once I'm done with them so I don't get confused, but here they're highlighted. So we look at each line and we make sure they have the same value. If they have the same value on every single line, they are equivalent. But we can see right away when we get to line 2, this first sentence has the value F, second sentence has the value T, so they have different values on line 2 and also again on line 3, but only matters if there's even one line where they're different. That means the sentences are not equivalent. So for equivalence and not equivalence, what you do is you fill out the truth table, then you compare the columns under the main operators, line by line. If they have the same value on every line, they are equivalent. If they're different on any of the lines, they're not equivalent. And I think sometimes in the book, he puts I don't know if I'll be able to do it here. Probably no room. He puts an asterisk next to the column or the lines where they're different, but or you can highlight them or whatever. So if they're not equivalent, that means you should be able to find at least one line where the two sentences have different truth values. Okay, next problem is number 4. There's only one atomic sentence here. It's M, so that's why we only have 2 lines on the truth table. M, there's only 2 possibilities. It can be true, it can be false. All right. So here we have M or not M. So again, N can be true on this line, false on this line, and not M then is going to be false and true. So now a disjunction comes out true as long as at least one of the disjuncts is true. So from our work in chapter 3, hopefully you recognize M or not M as a tautology, a sentence that always comes out as true. Okay. Now here the negation is the main operator, that's outside parentheses, so we have to do what's inside parentheses first. So again, M is T here, F here, not M is F here, T here. It's a conjunction, so they both have to be true, but this is false since it's false there, and this is false since it's false here. So inside the parentheses, it comes out false and false, but outside the parentheses, then when we negate 2 false sentences, we get true sentences. So the main operator here, again, we get a tautology. Right? Inside the parentheses is a contradiction because it always comes out false. So the negation of a contradiction gives you a tautology. Not surprising. Okay, so that's the truth table filled out. Now the next question we have to ask is, if I can get over back to my, are they equivalent or not? Well, compare these 2 lines. They're both true. These 2 lines are both true. So they have the same truth value on every line. So that means they are, in fact, equivalent. And really all tautologies are equivalent because they all have the same truth value. They all come out true. Similarly for all contradictions. Okay, number 6 is another 4-line truth table. Again, we have 2 atomic sentences, A and B. So whenever you have 2 atomic sentences, it's going to be a 4-line truth table, 2 to the n, 2 squared in this case, which is 4. Left-hand column, half true, half false. Next column in, we alternate twice as much. All right, so again, since we have negations, I'm going to go ahead and put these in. So A is TTFF, so not A is going to be F. Come on down here, F, T, T. Not B, since B is TF, TF, not B is going to be F, T, F, T. So now we can look at the disjunction. First line we have both are false, so a disjunction is false if they both come out false. Otherwise, as long as at least one comes out true, or if they both come out true, it is true. All right, so that's the truth table for the first sentence, not A or not B. Second sentence is not B conditional A. So again, not B is F, T, F, T. A we know is T, T, F, oops, F, F. It's a conditional, so it comes out true unless the antecedent is true and the consequent is false, which we have on the very last line. All right, so that's our 2 truth tables. Again, we're comparing the columns in the main operators. We're going line by line. So our very first line here, we find this comes out false, this comes out true. So again, they cannot they cannot be equivalent because they have different truth tables. And so we write not equivalent. And again, this one we really have two lines where they don't match up. But again, all you need is one. All right, our last two truth tables are, they have 3 atomic sentences each. Number 8 has NP and Q. So again, that's 3 atomic sentences. So you raise 2 to the 3rd power. 2 times 2 times 2 gives you 8. So that's why there's 8 lines here. Leftmost column, you got 4 T's, 4 F's. So you 8 lines, first half true, second half false. Next column in, alternate twice as much. This one was every 4. Now we'll alternate every 2. TT, FF, TT, FF. Next one, alternate again, twice as much. It's the innermost column, so it's going to alternate every time. TF, 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 TF. All right, so I'm going to do these just by looking over here. We're looking at the first 2 columns, and it's a disjunction. So they're both true here, here, 1 true here, 1 true here, 1 true here, 1 true here. But these last 2 rows, we have them both false, so we get false, false. I'm just going to center those. Okay, now we do N or Q. This is a little trickier because you have to ignore the P column and just look at the N and the Q column. But again, in the first 4, N is true, so we know that the whole thing's going to come out true. In the next one, Q is true. This one, they're both false, so we get an F. This one, Q is true again, so we get a T. And then this one, they're both false, so we get an F. Just center those. Okay, so now we can do the conditional. It connects them. So again, conditional is true if the antecedent and consequent are both true. So these ones all come out true. Here, though, we have a TF, so we get a false. T. So we've got 1 false, and the rest of these come out true. All right, now over here, N or Q. Now we're looking at just this same column. Check my text to make sure I wrote the problem down. N or Q, N or P, right? So it's just the same column here as it was right here. So I'm just going to write in T, 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 F, T, F, N or P is this column over here. So again, we'll just copy it. T, 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 F. F. Okay, so now we just have to do the middle connector, which is a conditional. So we got T, 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 F, T. Okay, so now if we go line by line, both true here, 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 both, nope, 1 false here, 1 true. So we see these lines down here at the bottom, 2 of them come out with different truth values. Here we've got false, here we've got true, here we've got true, here we've got false. So that means these 2 are not equivalent. Okay, I'm about out of time, so I'll stop there. Maybe I'll do 10, and then I'll do 1 or 2 from Q2, so just to show you how to set up the truth table for those ones in Q2. Or wait, I forgot I can go past 15 minutes. Right, I bought the deluxe version of this app because my kids are making videos on while playing video games. So, all right, so I do have a little bit more time. Okay, so A, biconditional, B, biconditional, C. So A, we can just copy and paste. I don't know if this will work. I never tried this. Let's see what happens. Okay, so there's our A column. B or C, or B biconditional C. Remember, the biconditional comes out true if they both have the same truth value. So here they're different, so it's false. Different, so it's false. Same, so they're true. Same, different, different. So I'm looking over at the B and C columns, right? So here they're both true, so the same. Here they're different, different, so they're false. Same, same, true, different, different, false. Okay, so now the main operator. So again, when they're the same value, it's true. If they're different values, it's false. False, true, and true. Okay, so now that's the first sentence. Second sentence, we'll just copy the C column here. And then we'll do A biconditional B. So we got to look back over the A and B column. When they're the same, this gets true. When they're different, it gets false. Like that. If I did that right, let me double check quick. False, 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 true. Okay, now we do the main biconditional here. True, false, false, true, false, true, true. Okay, now we compare columns under the main operator. Both true, both false, both false, both true, both false, both true, both true. So, since these are the same, oops, I didn't mean to do that. Since they're the same under every one, the columns are the same every time. Oh, did I miss a whole? Let me go down to this page. Looks like I missed that last row. Okay. So A here is false. B conditional is false, so this one comes out true. A, B is true. C is false. Wait. All right. I'm going to pause and double check this. I see what I did. This here, the B biconditional C, since B and C are the same there, that one should have been true. And this one then should be false. Okay. Sorry about that. Okay, now we, again, compare all the different lines, and they do indeed come out the same on every line, so those two sentences are equivalent. All right, now for extra credit this week, if you want to do some of the problems in Q2. So Q1 has truth tables set up for you completely, whereas in Q2 you're just given two sentences, right? So you have to remember a couple things. You have to remember to count the number of different atomic sentences, raise 2 to that power to get lines on the truth table. So for number 1, for example, P or Q is one sentence, Q or P is the other sentence. So that gives you 2 unique atomic sentences. So then you raise 2. Let's see, I'll try this to the second power, and that equals, of equals 4. So your truth table is going to have 4 lines. All right. Whereas if you have a 3 sentence, I think 3 is the maximum in Q2. So 3 sentence is going to be 2 to the third. Right? It'll be 2 raised to the third power, which equals 8. 2 times 2 times 2. Now, of course, if you only have one atomic sentence, then there's only 2 lines you need. But I think all of the problems in Q2 have at least 2, and at most 3. So do those if you're looking to do some extra credit this week, and post any questions you have to the relevant discussion forums.